Today, we're going to finish up the last little bit of stuff that we're going to be talking about. Last little bit of stuff about the moon. And then we're going to move on and start talking about the Earth. And I think I forgot to mention this over the past couple of days, but everything we're talking about this week is in Chapter 2. So if there's anything that you don't quite get from the lectures, you can always go to Chapter 2 to read up about the moon and the Earth. Okay? So, let's talk about this. Everything that we've talked about the moon so far has just been stuff that... stuff about how the moon looks, right? Do eclipses really have an effect on your life? No, okay? But there is one way that the moon actually physically affects the Earth, okay? Does anybody know what I'm talking about? What's the one way that the moon has an actual physical effect on the Earth itself? And that's going to be our main topic of discussion. So not what it uses, but it's the tides, okay? It's the tides, okay? We'll get to how it does it in a second. But yeah, the tides. Let's talk about the tides. First off, we're talking about high tide when the water goes up and low tide when the water goes down, right? Does anybody... We live in Florida. We're decently close to the ocean. Does anybody happen to know how many high tides there are in a day? How many high tides are there in one 24-hour period? How many high tides do we got? Twice. Yeah, there's two. Two high tides every day. So the water comes up twice every day. And that means there must be two low tides every day also. If the water comes up twice, it's going to go back down twice. So two high tides every day, two low tides every day. What time of day do high tides happen? What time do high tides happen? This might be a trick question. What time do high tides happen? So I see afternoon, I see morning, I see evening. You could say night too. It turns out, if you're not very familiar with the tides or with, using boats or something like that, you might not know this, but high tides don't happen at the same time every day. They're drastically different from one day to the next. It's actually every day the high tides are about 50 minutes later, okay? Every day the high tides are about 50 minutes later. And if you remember, I mentioned that 50 minutes before. There's something else that happens 50 minutes later every day that we talked about earlier in this week. What else happens 50 minutes later every day? What is it? It's related to the moon. Yeah, the moon rises 50 minutes later every day, right? Every single day the moon rises 50 minutes later every day. And the tides happen 50 minutes later every day. And that's how we realized that these things were related hundreds and hundreds of years ago. Specifically, that means we basically noticed hundreds and hundreds and hundreds and hundreds and hundreds of years ago that whenever the moon was rising, so here's the moon rising, every single time, no matter what time of day the moon was rising, when it was rising, it was always low tide, okay? When the moon was rising, it was low tide, okay? Now, after that point, the moon came up in the sky, and if we had low tide when it rose, what's the water going to do as the moon rises? What does the water do as the moon gets higher in the sky? Which way does the water go? Yeah, it rises also, right? It rises. So as the moon moves from the horizon up the sky, the water's going to get higher and higher and higher and higher. Until we get the moon directly over our head, and that's going to be your high tide, okay? So at moon rises, we're going to get a low tide. The water rises with the moon until the moon is directly above our head, and that's going to be our first high tide of that rotation, right? Now, Does anybody remember what the fancy word for straight over your head? What's the fancy word for straight over your head? Starts with a Z. What's that? So we get a high tide when the moon is at at the zenith. So when the moon is at the horizon, we get a low tide, and when it's at our zenith, we get a high tide. Okay. Now, if we got a high tide when the moon's up here, then the moon is eventually going to start coming back down, and then the water's going to come back down. Can you tell when the next low tide is going to be? When's the next low tide going to be? When the moon gets where? Or when the moon starts to do what? Another way to put it. I'm getting close. Yeah, when the moon sets again, right? When the moon sets again, you're going to get another low tide, okay? So, again, low tide when the moon rises, high tide when it's at your zenith, and then another low tide when it sets. But we're not done, because that's our two low tides, right? Low tide, low tide, low tide, low tide. But we only got one high tide. So where's the moon going to be? Where are you going to see the moon when the other high tide happens? Well, if the moon's just set, where are we going to see the moon when the other high tide happens? A little bit of a trick question on that one. Where are you going to see the moon? Yeah. Got some people trying. Let's see what we get. We can't see it. Right. We can't see it because it's going to be on the exact opposite side of the planet as your zenith. Okay? So, again, when the moon came up over here, we're getting a low tide, high tide, low tide, and then when the moon goes directly under you, it's going to be another high tide. Okay? So, two low tides, low tide, high tide, right? Low tide, high tide. These are positions of the moon, by the way. I'm not just dancing over here. So low tide, high tide. Everybody good? Okay. Now, check it. That's the tide dance. All right. Now, here we go. It took us a long time to figure out what the moon was actually doing, and one of you guys have already actually mentioned this. It wasn't until after Newton that we were able to figure out how the moon made the tides happen. What is the moon using to make the tides happen? How is the moon making the water come up when the moon's up here? What's it using? And the same thing over here. Yes, it's using gravity, right? It's using gravity. So Newton figured out that everything with mass has gravity, and the moon has mass. So until Newton figured that out, we didn't know that the moon was pulling things like the Earth pulls things. And so the moon is able to pull on the water. But let's think about this, because there's a little bit of a confusing thing here, okay? Because just saying gravity's not enough, okay? It makes sense that when the moon is up here, it would pull the water up and we get a high tide. That makes sense, right? It also makes sense if we get a low tide when the moon's over here, because if the moon's over here, it's going to pull the water that way. And if the water gets pulled that way, it's basically causing our water on this part of the planet where we're standing to go down. It's basically stealing our water, sort of, right? Same thing over here. It pulls the water that way, so it's a low tide for us because it's taking the water over there. Those ones make sense. But when the moon is underneath us, which way is it going to pull the water? Don't worry about what kind of tide we get. If the moon is under us, which way should the water be pulled? If the moon is using its gravity. Yeah, the water should be pulled down, right? The water should be pulled down, but we get a high tide, meaning it looks like the water went up, right? So this part is confusing. It's weird. It doesn't seem to make a lot of sense that we get a high tide when the moon is under us. because gravity doesn't push things away. So what's happening here? Like I said, it's a little bit more complicated. Let me draw some diagrams to help you understand it. So check this out. Here we go. Here we go. Let's assume some mad scientist blew up the moon. Just blew the moon up. Okay? Just blew it up entirely. While I'm drawing this, if somebody blew up the moon entirely, just like vaporized it, there's no moon left, how many high tides would we have in a day? How many high tides would we have with 0 moons? And I'll check back to see what you guys answer. Yeah, we would have no tides. That's correct. We would have no tides at all. So let's say... Uh-oh. Come on. I hate this machine that the school gave me. Let's restart it one more time. Here we go. And there we go. Okay. So let me zoom in a little bit. So let's say that this is the Earth. I've labeled it with an E for Earth. And let's say that this is the ocean of the Earth. And real quick, the ocean of the Earth is not that deep. I'm drawing it much deeper than it really is, just so we can see it better, okay? And let's say that the moon used to be up here. Like, this is where the moon was, okay? And let's say that we decided, uh-oh, that's bad. We want to have a moon. It's a bad idea. All of our boats are stuck in the bay because there's no high tide to get the water level deep enough to get our boats out of the bay. Oh no! So we're going to create a new moon and just pop it right back in place. Like, I don't know how we do this. It's mad science. We're just going to just pop a moon right there. Boom. Okay? Now, here's the important part. Here's the important part. Newton didn't just figure out that the moon has gravity. He figured out some other things about gravity. Specifically, that distance matters, right? The distance you are away from, in this case, the moon, is going to determine how much gravity you feel, okay? So, is every part of the Earth and the ocean going to feel the same amount of gravity? No. Which part of the Earth and ocean is going to feel the most gravity from the moon when we turn the moon on? Which part on here will feel the most gravity from that moon? The part closest to the moon. That's correct. The part that is closest to the moon. So I'm just going to put a number 1 on this ocean right here. That ocean is the closest part of the Earth to the moon when we turn the moon on. The top right here. Yeah, it's number 1. Now, the Earth itself will feel the gravity of the moon, but I'm going to put a number 2 on the Earth because it doesn't feel as much gravity as this ocean does, because it's further away from where the moon's going to be. And then this ocean back here, I'll put a 3 on it, this part of the ocean, because that's the farthest part away from the moon. It's going to feel the least amount of gravity. But here's the important thing. All of these parts are going to feel gravity from the moon. So when we turn the moon on, which direction in this picture are all of these parts going to move? They're all going to move because of the moon's gravity, and they're all being pulled by the moon. So which way will they move on this picture? Up, down, left, right, in. Yeah, they're all going to move towards the moon. Up, right? Up in this picture. So every one of these parts will move up when we turn the moon on. Okay, so let's say we turn the moon on. Like, this is moon off. And let's say this is moon on over here. So we're going to turn the moon on. And I need to draw all of these parts where they end up. And I'm going to exaggerate this. Like we said, every part, the entire Earth is actually going to move towards the moon. When the moon is here, the entire Earth is pulled a little bit in that direction. Okay? When the moon is here, the entire Earth is pulled a little bit in that direction. But, again, you guys said that part 1 got the most pull of gravity. And that means it's going to move the most. Okay? Part 1 is going to move the most. So here we go. Let's imagine this ocean ended up way up here. So it moved that much. That was the pull that Ocean 1 received. Now, the Earth itself also moves up, but not as much because it doesn't get pulled as hard. So the whole Earth is actually going to end up moving up. But it only got moved a medium amount. That's part 2. That's the Earth. And then here we go. Don't overthink this. Which way is 3 going to go? Also up. But how much is 3 going to move up in this picture? How much? A lot? A little bit? A medium amount? How much is 3 going to move up? Not too much, right? Not much at all. Just a little, yeah. So that means everybody's racing to get to the moon, but Ocean 3 kind of gets left behind. It only moves up just a little bit. But here we go. Here's the thing. That means the water here got deeper and the water here got deeper. Those two parts of the water on our planet got deeper. This one because it was ahead, and this one because it was behind. Okay? But there's only a certain amount of water, so what's going to happen to the water on the sides? Where did this water have to come from? What's going to happen to this water on the sides if the water got deeper in these two places? What's going to happen to this water? Over here on these sides. Yeah. Basically, for the water to get deeper in these places, the water had to come from somewhere. So that means the water on the sides is going to get shallow because that's where the water was stolen from. So essentially, here's the thing. Everybody thinks of the Earth and our ocean being a perfect circle like this, but because of the pull of the moon, we're actually stretched out a little bit. I'm getting some freezing here. Anyway, the Earth gets stretched out a little bit. It's not nearly this extreme. You probably have seen pictures of Earth from space, and you probably didn't notice that it was stretched out a little bit like an egg. But the Earth itself and the oceans are stretched out like this. Now, here we go. Let's put it all together. If you were standing here, what kind of tide would you have? If that's you, what kind of tide would you have right there? High tide or low tide? High tide. You'd have a high tide if you're standing right there. And don't overthink this. Which way would this person have to look to see that moon? Where in the sky would this person look to see the moon if he's standing right here? Up, right. Towards their zenith, right? Up. That's correct. You would also get a high tide if you were standing here, and from this person's point of view, where's the moon? It's underneath their feet, okay? And then what kind of tide would you have over here? What would this person have? That would be a low tide, right? And which direction would this person right here, which direction would this person look to see the moon? Where would they have to look in the sky to see the moon? Don't bite me. My bandit cat just came in and bit my legs. Sorry, guys. Yeah, they would have to look off to their side, right? From their point of view, the moon is to the side, so they're looking at the horizon, okay? They're looking at the horizon. So just like we said, and it would be the same thing if you were standing over here. So if the moon is to your side, the water will be low. If the moon is above your head, you get a high tide. And if the moon is below your feet, you get a high tide. So basically, now we can really explain the high tides like this. When the moon is above you, it's okay to think the water on my side of the planet came up more than the Earth went up. So the water got high. The water went up more than the Earth did. But if we were to turn this picture upside down, from this person's point of view, everything's being pulled down, but the Earth that you're standing on, the floor, got pulled down more than your water did. So your water got left behind. It's not that the water got pushed up, it's just that the water got left behind when the ground went down. That's the point of view on this side. It's a little bit confusing to get into your head. It's okay. And finally, last thing I want to say from this figure is this. The reason that we get 2 highs and 2 lows every day is that it takes a whole month, about 4 weeks, for the moon to move all the way around the Earth. So that means in one day, the moon is basically in the same place all day. It just stays roughly there in its orbit. But during that day, what does the Earth do while the moon's just hanging out up here? What does the Earth do every day? Physically. Here we go. What does the Earth do? Yeah, it rotates. It spins once a day. So while the moon hangs out roughly in the same spot all day long, the Earth spins once a day inside of this stretched out ocean. And so that means you're going to spin through high tide, low tide, high tide, low tide every day. And then the next day, the moon is moved over a little bit, and so you're going to hit those tides at a slightly different time. And then the next day, the moon is moved over a little bit again. So if you remember, a couple of days ago, we learned how to use that figure to figure out when a moon is going to rise and set. That means if you know when a moon is rising, you know when low tides are going to be. And if you know when the moon is going to be over your head at your zenith, you know when the high tides are going to be. Sorry, guys. My cat keeps biting me. I think it's hungry, but we're going to keep going. It's not time to eat yet. It's not time to eat, okay? So just bear with this cat. All right. Sorry, guys. Now, here we go. So, that's the regular tides. All right.